Alright class, today we're going to be focused on area, so this includes area of rectangles, parallelograms, triangles, trapezoids, and you need to make sure that you have your mathematics star chart in front of you. This star chart is your best friend. It gives you all of the information that you need to know. This is given to you on any test, any quiz, any STAR test, so this is really like a cheat sheet. You just need to be able to use it. Alright, so let's look at where we were last year and where we're going to be this year. So as a 5th grader, you had to represent and solve problems related to perimeter, area, and volume. So let's remember that perimeter is the distance around an object. It's like the edges. Area is what covers something, and volume is the amount that can fit inside something. So as a 6th grade student, you're going to need to be able to choose the correct formula to use and solve for area and volume. And you also need to be able to manipulate that formula to work backwards. So sometimes they're going to give you the area and expect to be able to find the length or the height. Alright, so the first thing we're going to do is we're going to find the area of a parallelogram. So these are the steps that I want you to write down in your spiral. So step 1, you're going to write down the formula. Step 2, you're going to plug in the correct numbers. And step 3, you're going to work it out and solve it. So I'm going to give you about 20 seconds to write down your steps. And when you're finished, I want you to put your pencil down in front of you. Alright, looks like everybody's pencil is down in front of them. So, let's go back. It tells us exactly what kind of shape we're working with here. This is a parallelogram. So I'm immediately going to go to my formula chart. I'm going to locate where it says parallelogram, and I'm going to go to my formula, and I'm going to write this down. A equals base times height. I want to remind you that a base is something flat that you can sit on, so our base on this problem is 59 centimeters. Our height is always going to form a 90-degree angle. So if you look in here, this forms a 90-degree angle. This does not. A slant will never ever be your height. You always want to look for that 90-degree angle. Okay? When two things are bumped up next to each other, it means to multiply. So we're going to multiply 59 times 37. Now you guys can do the multiplication. So when you have multiplied 59 times 37, I want you to put your pencil down in front of you. Alright, I want you to turn to your elbow partner, and I want you to check each other's multiplication. So see if you got the same answers. Alright, if you're sitting at a desk with a prime number, please stand. And if you rode the bus to school today, stay standing. Alright, Heather, what'd you get? 2,183. Excellent. Now let's add something to your answer. So because we're dealing with area, we're going to put our label on it, which is centimeters, and we're going to say squared, because when we're dealing with area, we want to label everything as squared units. Alright, example problem number 2. We're going to work with a triangle. So our steps are the same. The only thing that has changed is our shape. Okay, so first step, we're going to write down our formula. We're going to plug in our numbers, and we're going to work it out and solve it. So what I'm going to do is I'm going to give you 10 seconds. I want you to look at your formula chart. I want you to take your finger, put your finger on the correct formula. Look with your elbow partner, make sure y'all both have your finger on the same formula. And then I'm going to call out to see who can give me the correct formula to use. Remember, you have about 10 seconds. Feel free to ask your elbow partner for help. Alright, I'm going to use my cup of sticks, and I drew out desk number 20. Excellent. A equals 1/2 base times height. So what's the difference between this formula and the last formula that we used? Good, it has that 1/2 in here. And a triangle is half of a parallelogram. Alright. So we're going to go ahead and bring this 1/2 straight down. The base of our triangle is 6 feet. And remember, when we're looking for the height always forms a 90-degree angle. Our height will never ever be a slant. So our height is 5 feet. Alright, so let's go ahead and do 1/2 times 6, or half of 6 is 3. And 3 times 5 is 15. And let's add our label on here, which is feet. And because we're dealing with area, it's going to be feet squared. We have another shape to look at. We're going to add in our trapezoid. I want you to notice that our steps have stayed the same. We're going to write down our formula. We're going to plug in our numbers, and then we're going to work it out and solve it. So let's find that formula on our star chart. Ooh, this formula looks pretty tricky. So let's talk about this formula. Everybody, let's go ahead and write it down together. We have A equals 1/2 B1 plus B2 times our height. Now these B's in here stand for base 1 and base 2. Our bases will always be parallel to one another. So on this particular trapezoid, our bases can be 5 and 9, and it doesn't matter which one is you put as base 1 and base 2. So let's go ahead and plug in our numbers. I'm going to bring down my 1/2. Base 1 I'm going to put as 5, which means my base 2 has to be 9. And remember, our height is always going to form a 90-degree angle, so my height is 6. Now, because we have a lot of things going on in here, we need to work this like an order of operations problem. Which means I need to figure out what I need to do first. So I'm going to use my cup of sticks here, and this time I pulled out desk number 2. Alright, Mark, can you tell me what we do first using our order of operations? Excellent. We're going to use our parentheses, our grouping symbols first. So we're going to do 5 plus 9, which is 14. Now I'm going to copy down everything else exactly like I see it. Now we're still going to use our order of operations. We don't have any exponents, so we're going to multiply and divide in the order that we see it. And we run into half of 14, which is 7. And then 7 times 6, which is 42. And we want to put our label on it, which is inches squared. Excellent job. Alright, so here is where I would let them practice, and I would not teach all these shapes in one day. I would teach one shape every day. So I would have triangles all in one day. I would have trapezoids all in one day. I would do versatiles and let the kids practice. I would pull a small group. You could do a scavenger hunt if you feel like they really, really got it. And desktop travelers would also be good to get them up and moving. They should have a good 20 minutes to practice on their own. So an exit ticket out the door this day, I would try and do a who's correct. This is where I would put 2 sample problems up on the board. One would be worked correctly, one would not, and I would have the students come up and tell me who solved it incorrectly and tell me why they solved it incorrectly. So I would have them find the mistake in the problem. So I wouldn't want them to tell me who got it right. I would essentially want them to tell me who got it wrong, and I would want them to find the mistake. And I would have them write it on a sticky note or write it on an index card and give it to me on the way out the door.